Matrix assisted laser desorption ionization is called MALDI. We use a MALDI plate like this. In this plate, we already have grooves in which you can put your sample. Put your sample in the powder form, which is already mixed with some volatile component. The matrix, that is called matrix. The matrix is a light absorbing substance that is excitable by a laser. So in this method, a laser pulse is directed onto a sample, which is mixed with a light absorbing matrix, causing the matrix to rapidly vaporize and carry the analyte molecules into the gas phase, where they become ionized and then they can be sent to mass analyzer and detected. Typically, it produces mostly singly charged ions, H plus ions, which simplifies spectrum interpretation, because when you know that all the charges are plus one charge only, then it's easy for you to identify the molecular weight. MALDI is often well suited for analyzing large molecules like proteins, peptides, polymers with high sensitivity. And this is how the spectra of MALDI looks like. Relative abundance versus mass to charge ratio. Whereas in electrospray ionization, a fine mist of the sample solution is sprayed through a high voltage capillary, causing the droplets to shrink and eventually produce charge ions. So if you can see here, two concentric steel tubes, they are carrying the liquid and nebulizing gas. After nebulization, additional gas is used to dry the droplets. So you'll put your sample here, liquid sample, it will convert into the charge ions. Whereas in case of MALDI, you need a dry sample, which you have to dissolve in your volatile buffer. Now, as the droplets shrink, the charge density increases to the point at which the droplets are no longer stable and ions are released from the liquid matrix into the vapor phase. Ions enter the mass analyzer at an angle to reduce the entrainment of neutral molecules. So in ESI, often it generates multiple charge ions, allowing for better mass accuracy and analysis of larger molecules by distributing the charge across the molecule. So in ESI, it is usually involves dissolving the sample in a liquid solvent and directly injecting it into the electrospray source. This is commonly used for analyzing complex mixture of molecules, including peptides, proteins, small molecules, which are often coupled with liquid chromatography for separation. A quick comparison. ESI adds a lot of charges to protein, allowing a large mass range, and spectra contains a series of peaks that differ by a single proton. Characteristic charge distribution is there, whereas in MALDI, most molecules pick up only a single H plus charge and it is not inline. That's all for the video.